In this video, we'll be setting up OpenVPN remote access on Pfsense with NPS radius authentication, and we'll add Microsoft Entra MFA on top of that. Here is the network diagram of my lab setup. A remote user with OpenVPN Connect client installed on a Windows computer terminates an OpenVPN connection to the WAN IP of Pfsense and be able to access a resource behind the firewall. The two usernames that we'll be utilizing are OpenVPN_user1 and OpenVPN_IT_user1. OpenVPN_user1 is a member of users group and will be allowed to access the file server 192.168.10.100 on SMB port 445. OpenVPN_IT_user1 is a member of IT group and permitted to access anything on 192.168.1.0/24 subnet for the purpose of managing Pfsense on 192.168.1.1 and the switch on 192.168.1.205, both via HTTPS. The same user also will be allowed to manage the file server 192.168.10.100 and AD server 10.10.10.220, both via RDP. The public WAN simulated IP 192.168.8.215 configured on Pfsense is listening for OpenVPN connection on UDP port 1194. Pfsense will then pass the primary authentication radius request to 10.10.10.220 running NPS and validate the user from Active Directory. Upon successful first authentication, it passes the request to the NPS extension that triggers a secondary authentication to Microsoft Entra MFA. The user that is set up for MFA on their phone using Microsoft Authenticator app will get a push notification requiring to approve the sign-in request. Once a remote user completed the login process successfully, it will then be able to establish an OpenVPN connection and access a permitted network resource. Let us take a look at the Active Directory /NPS radio server. It is a Windows Server 2022 standard OS with an IP of 10.10.10.220, and I have already set up Active Directory and NPS roles on this one. In Active Directory users and computers, I have this OU called OpenVPN_users to contain the remote users and groups. There's one user at the moment that is OpenVPN_user1 and one group named users group. OpenVPN_user1 is a member of users group. Under users group properties, we can also find that OpenVPN_user1 is listed in here as a member. We'll open Network Policy Server or NPS to examine the configuration. Under Radius Client, I have added Pfsense Firewall in here already. Pfsense FW Properties shows this is enabled. Friendly name is Pfsense FW. IP address is 10.10.10.1. That is the DMZ interface IP. For shared secret, ensure to match what is set in here on Pfsense Radius configuration later. Under Policies, I have a connection request policy named Pfsense OpenVPN. This policy is enabled. Under Conditions, there is only one condition, that is client IPv4 address 10.10.10.1. Under settings, all of the settings under in here are just the default. In network policies, I have one in here called Pfsense OpenVPN policy. This policy is enabled. Grant access is selected. Under conditions, I have added a condition to match a user groups, and that group is users group. Under constraints, the authentication method selected is unencrypted authentication, PAP or SPAP. Under settings, everything in here is just the default. In summary, a radius request coming from the firewall IP 10.10.10.1 with the user from the users group is matched with these policies in place. Let's jump to Pfsense Firewall Web GUI. This is running version 2.7.2. First thing to do in here is to add a radius authentication server. We'll go to System, select User Manager. Under Authentication Servers tab, Local Database is the default authentication server. Click Add. I'll name this Radius NPS. Type is Radius. Choose PAP for the protocol. For the hostname or IP address, enter the Windows Server IP 10.10.10.220. For the shared secret, enter the same shared secret defined from the configured radius client in NPS. Leave the authentication and accounting selected for services offered. For authentication and accounting ports, I'll leave it as it is to the default ports. I did not change the listening default ports at the NPS, so it should be on ports 1812 for authentication and 1813 for accounting. For authentication timeout, I'll put 30 seconds to account for the MFA process so that user has time to receive and accept the connection request on their phone. For the radius NAS IP attribute, select the DMZ IP 10.10.10.1. Click Save. We just added a radius authentication server that this firewall can talk to for user authentication. Let us test if authentication works. We'll go to Diagnostics, select Authentication. Select the authentication server named Radius NPS that we just added. Enter the username openvpn_user1 and its password. Click Test. User openvpn_user1 got authenticated successfully. Next step is to create certificates for OpenVPN. We go now to System, select Certificates. Under Authorities, click Add to create a certificate authority or CA certificate. I'll name the CA certificate OpenVPN CA. Method to select here is create an internal certificate authority. Check the box to add the certificate authority to Pfsense Trust Store. For key type, digest algorithm, and lifetime, I'll just leave it as the default. For common name, we'll call this OpenVPN_CA. And for the rest of the settings, these are optional, no need to fill it out, click Save. We just created a self-signed CA certificate that we can use for OpenVPN. Next is to create an OpenVPN server certificate that will be signed by the CA. We go to Certificates, click Add/Sign. Same method that is to create an internal certificate. I'll name this OpenVPN server certificate. For certificate authority, select the CA certificate that we created earlier named OpenVPN CA. For key type and digest algorithm, leave it as default. For lifetime, I'll lower it down to 365 days. For common name, I'll just put here OpenVPN_server_cert. For subject components, I can leave this blank for now. For certificate type, choose Server Certificate. No need for alternative names, click Save. We just created an OpenVPN server certificate signed by the OpenVPN CA. Let us start configuring OpenVPN. We go to VPN, select OpenVPN. One thing to note that this client export tab will not show up in here by default. A package name called OpenVPN-client-export is required to be installed first. If you don't have this yet, download and install the package by going to System, select Package Manager. I have already installed the package OpenVPN-client-export. This is used for exporting pre-configured OpenVPN configuration file. If not installed yet, select Available Packages and search for the package name. Since I have it already, it will not show up when searching for it. We go back to VPN, select OpenVPN. Under Servers, click Add. We'll call this OpenVPN Remote Access. For server mode, we'll try out first Remote Access User Auth. This will give us a foundation that remote user can be authenticated. Then we'll change it to Remote Access SSL/TLS plus User Auth and see the difference. Select Radius NPS as the backend for authentication. For device mode, we'll go for TUN-Layer 3 tunnel mode, since it's the most common and compatible mode across all platforms. For protocol, we'll go for UDP on IPv4 only. For interface, this is the WAN interface that will accept incoming OpenVPN connection. I'll leave the local port this OpenVPN server will be listening at on 1194. For TLS configuration, leave it checked to use a TLS key. Check also automatically generate a TLS key. For peer certificate authority, select the CA certificate OpenVPN CA. For server certificate, pick OpenVPN server certificate. I can leave the other settings as default. For IPv4 tunnel network, I'll designate a network address of 172.20.0.0/24. Make sure this is a unique network address and no conflict. Once remote users get connected over OpenVPN, this OpenVPN server will list out an IP address from the network address range that we specified in here. We'll not use IPv6 tunnel network. For redirect IPv4 gateway, this will dictate the traffic whether split tunnel or full tunnel. When this is checked, all traffic from the remote user will get routed to the firewall, or in other words, it will be a full tunnel. Leave it unchecked, which means split tunnel, since I wanted to reach only specific resource behind the firewall. For IPv4 local networks, this will be the permitted network address or IP that the remote user can access. In our topology to cover 192.168.1.1 and 192.168.1.205, I'll enter the network address 192.168.1.0/24 and then add a single IP address 192.168.10.100/32. There are a couple of settings that I can leave as default. I will just enable or configure what is needed to get this working. For dynamic IP, I'll check disallow connected clients to retain their connections if their IP address changes. For username as common name, I'll check this box, use the authenticated client username instead of the certificate common name, and this is useful for client-specific override in matching the username. We'll see this one how it works later. For gateway creation, we'll select IPv4 only, click Save. We just created an OpenVPN server that will accept connection going to the WAN interface listening on UDP port 1194. Remote user will be assigned an IP address within the tunnel network address 172.20.0.0/24. The mode type is user authentication. Next step is to add firewall rules. We go to Firewall, select Rules. Under WAN, click the Add icon that will place the rule at the very top. We'll add a firewall rule that will accept incoming UDP port 1194 on the WAN interface for OpenVPN connection. Protocol is UDP. For source, we'll leave it any. For destination, select WAN address, which is the object name for the WAN interface IP 192.168.8.215. For destination port range, this is UDP port 1194. Leave it other and enter 1194 in the custom from and to fields. For the description, I'll say allow OpenVPN UDP port 1194. Click Save. We just created a firewall rule that will allow incoming UDP port 1194 for OpenVPN to the WAN address. Next is we go to OpenVPN tab. We'll add a firewall rule to allow OpenVPN_user1 to have access to the file server 192.168.10.100 over SMB port 445. There is no rule by default under OpenVPN. Click Add. SMB port 445 is TCP, so we'll leave the protocol as TCP. For source, this should be the OpenVPN tunnel network address, that is 172.20.0.0/24. For destination, this is the file server IP address 192.168.10.100. For destination port range, we'll select MSDS or Microsoft Directory Services 445. This is equivalent to SMB port 445. In the description field, I'd say OpenVPN remote users access to file server SMB. We just added a firewall rule to allow incoming TCP traffic from OpenVPN network address 172.20.0.0/24 going to the destination IP 192.168.10.100 on SMB port 445. Next is to export an OpenVPN configuration file. We go to VPN and select OpenVPN. Click Client Export. There is only one remote access server. Scroll down. Under OpenVPN clients, we have this authentication only, no cert, none for the certificate name. Under Export Inline Configurations, we'll click on this Most Clients button, and it will download the configuration file that is compatible on Windows, Mac OS, and Linux. The file that we just downloaded is pfsense-udp4-1194-config.ovpn, and I have sent this file to the user. Let's jump to the remote computer. I have installed the OpenVPN Connect client already in here. You can download this OpenVPN Connect application by just searching it on a browser. I downloaded the OpenVPN Connect version 3. The OpenVPN configuration file that was downloaded from Pfsense is in here already. We can double click on the file and it will import it automatically to OpenVPN Connect, or we can import it manually by clicking Upload File. I'll cancel this and import the configuration file by double clicking the configuration file. The profile name shows the WAN IP 192.168.8.215 and the file name itself. This profile name can be changed, but I'll leave it as it is. Server host name is the WAN IP address. Enter the username openvpn_user1. Click connect. Enter the password and click OK. It got connected. If we scroll down, we can find the username. The private IP assigned is 172.20.0.2, which is within the tunnel network 172.20.0.0/24 subnet. The server IP is the Pfsense WAN IP 192.168.8.215 that is running OpenVPN server. The server public IP is also the Pfsense WAN IP. Port number is 1194 and protocol is UDP v4. Let us test if we have connectivity to an internal resource. Open command prompt and I'll ping first the firewall LAN IP 192.168.1.1. It is not reachable. OpenVPN_user1 is only allowed to access 192.168.10.100 over TCP port 445 and not be able to access anything. Pinging the switch web management IP 192.168.1.205 is also timing out or not reachable. Pinging 192.168.10.100 is also timing out. Why? Remember the firewall rule we added under OpenVPN is only for TCP port 445 to destination 192.168.10.100. I'll ping the AD server 10.10.10.220 and as expected it is timing out. We'll open File Explorer and enter //192.168.10.100. We got a successful SMB connection and we have access to the shared folder. We can create a file, view a file, and delete a file since I have allowed read and write permission to this shared folder to everyone. Back in Pfsense Web Management, we can verify the connected remote user by going to Status and select OpenVPN. We can find the common name, which is the username OpenVPN_user1. Real address is the source WAN IP of the remote user machine and its source port. Virtual IP address assigned is 172.20.0.2. We have traffic usage for bytes sent and bytes received. Let us verify the firewall rule usage as well. We go to Firewall, Rules, OpenVPN. We can see some traffic usage and we know that this rule is working. We go to VPN and OpenVPN. Select Client Export. As you noticed, the configuration file is not specific to a user. This configuration file can be used to any user and they will just authenticate with their username and password. How can we have an OpenVPN configuration file that is based on a per user certificate? We go to Servers, double-click on the existing OpenVPN server configuration to edit it. Server mode type is currently set as a remote access user auth. We'll change this to remote access SSL TLS plus user auth. With this change, user certificate will be needed. That is all we need to change in here, then click Save. We just changed the OpenVPN server remote access method type to SSL/TLS plus user auth in order to have a per user certificate configuration file. Go to Client Export and let's see what we have for the OpenVPN configuration file. Under OpenVPN clients, we don't have anything to download. Why is that? Since we changed the server mode method to include SSL/TLS besides user auth, we need to create a user certificate first. We go to System, Certificates, click the Certificates tab, click Add. We are still creating an internal certificate here. For the descriptive name, we can put any name, but for simplicity, I'll enter the exact username openvpn_user1 so that I know right away that this is for the specified user itself. For the certificate authority, we have only one to select, OpenVPN-CA. For common name, this should be the exact username, openvpn_user1. For the certificate type, choose User Certificate. Click Save. We just created a user certificate for the username openvpn_user1. We'll go back to OpenVPN and Client Export. This time we have a configuration file entry, and it says certificate with external auth. And the certificate name is the username openvpn_user1. We can now download the configuration file for this user. See the difference in the configuration file name. The new OpenVPN configuration file name includes the username in it. Back at the remote computer, we can double-click the configuration file for this openvpn_user1 to import it to OpenVPN Connect client. We got a successful connection. The same details we can see from the previous connection. Connectivity-wise, it should still be the same since we have not changed any firewall rule. We just changed the method of connection to per user certificate. For the final part of this video, we'll integrate NPS radio server with Microsoft Entra MFA. Here is the documentation I followed for the integration. Refer to the link in the description. Basically, what we need to install in the server running NPS is the NPS extension that will send the authentication to Microsoft Entra as secondary authentication. This guide starts explaining how the NPS extension works. It mentions about the prerequisites in terms of the license, softwares, and libraries needed. We need to copy the tenant ID from Microsoft Entra as part of the configuration during the NPS extension installation. In this first tab, I'm logged in already to Microsoft Entra Admin Center. To get to the tenant ID, we go to Overview. We can also find the license type, that is Microsoft Entra IDP2. We'll check the users that I have in Entra. We go to All Users. I have filtered this out to show only the OpenVPN users that is synced from on-prem AD to Entra. We have one user that is OpenVPN_user1. How did OpenVPN_user1 from on-prem AD synced up in Entra? We go to Hybrid Management and select Microsoft Entra Connect. Click Manage. Under Manage from On-Premises, Connect Sync, I have downloaded this Connect Sync agent or application that will allow to sync on-prem AD users to Entra. In the AD server, this is the agent that I have already installed called Azure AD Connect. I'll double click to launch it. This is what it looks like when it is already set up. Back in the guide, these are the URLs that the NPS will communicate to Microsoft Entra. You may need to allow these if there is a strict firewall rule in place. Before installing the NPS extension, here are some preparations to be done. Enable the NPS role on a domain join server, which is already done. Sync domain users to the cloud. This is also done by downloading and running that Connect Sync agent at the on-prem AD server, and we'll verify that user openvpn_user1 has been synced up. The authentication method that I will be using here is PAP, which we have configured already in the NPS network policy. We need the users to be registered for MFA. This is not done yet. I have not registered openvpn_user1 for MFA. To set up the user for MFA, we need to go to this URL, https://aka.ms/mfa setup. Back at the remote user machine, open a web browser and enter the URL https://aka.ms/mfa setup. After signing in the user openvpn_user1, an action is required to set up Microsoft Authenticator app. Click Next. This page is telling us to download Microsoft Authenticator app, which I have already installed on my mobile phone. Click Next. To allow notification, we can select work or school when adding an account. Proceed to Next. We are required to scan the QR code and will launch Microsoft Authenticator app on our mobile phone. Click the plus sign to add an account. Select work or school account. Scan the QR code. We can see at the bottom now that openvpn_user1 has been added. We can click on Next. It is testing now to approve the number. The Authenticator app did receive the notification for openvpn_user1. Enter 65 and click Yes. It has been approved. We go Next. We are about to complete the setup and will use phone number to receive a code. We just registered openvpn_user1 for MFA. Let us verify the user in Microsoft Entra. Go to Authentication Methods. The default sign-in method is Microsoft Authenticator Notification. Under System Preferred MFA method, Phone App Notification is enabled. Back in the guide, we are done registering a user for MFA. Next is to download and install NPS extension onto the server running NPS. I have already done this in advance. We are also required to run a script in PowerShell. The script comes with the NPS installer and need to go to this folder where the script is located. And run this file. The script will download some packages, and during the process it will ask for the tenant ID of Entra. This guide also provides some troubleshooting steps, and we'll take a look at this one later. Let's jump to the server. This is the NPS extension file name that has been downloaded and installed. When double-clicking on it, this is what the screen looks like. NPS extension for Azure MFA. Back on Pfsense Web Management, we'll go to Diagnostics and select Authentication. Let's test if MFA works. After clicking Test, I receive a notification on my phone to approve sign-in for OpenVPN_user1. Note the timestamp at 12:21. Click Approve. User OpenVPN_user1 authenticated successfully. I'll open Event Viewer in the server to verify the log entry for Azure MFA, expand Applications and Services logs, expand Microsoft, expand Azure MFA, expand AuthZ, select AuthZ OPTCH. Remember that timestamp 12:21 earlier when the notification was received on the phone. This log entry shows the same timestamp when NPS extension for Azure MFA was triggered. Access accepted for user OpenVPN_user1. At the remote user machine, we'll reuse the same imported OpenVPN configuration file for user OpenVPN_user1. I'll delete the first one. We'll now try to connect. I received a notification on my phone and clicking Approve. Take note of the timestamp at 12:24. We got connected. Back at the server's event viewer, right-click and refresh to display newer entries. We have a recent entry here at 12:24. This event is indeed the NPS extension for Azure MFA, and access was accepted for user OpenVPN_user1. We are done setting up this user OpenVPN_user1. Now we'll set up user OpenVPN_IT_user1. I'm member of the IT group and permitted to access 192.168.1.0/24, 192.168.10.100, and 10.10.10.220. Let's start at the server, open Active Directory users and computers to create the user and group. User logon name is OpenVPN_IT_user1. Next is to create the group IT group and then add OpenVPN_IT_user1 as a member to the IT group. In Microsoft Entra Admin Center, the newly added user will not get synced yet. The Azure AD Connect agent on the server syncs user every 30 minutes by default. We'll not wait for that and have to do a manual sync. Launch Azure AD Connect, click Configure, select Customize Synchronization Options and click Next. Ensure you have the administrator Entra account username entered. The selected OU that will sync up to Entra is the OpenVPN_users OU. Click Next. No need to change the optional features. Click Configure to start the synchronization process. Microsoft Entra Connect sync configuration succeeded. We can verify now in Entra. In Entra, let's search one more time with keyword OpenVPN. This time OpenVPN underscore IT user 1 syncs up in Entra. The authentication method for this user is not set up yet. We see in here that default sign-in method says no default. Next is to register this user for MFA. This is another remote machine and I don't have OpenVPN Connect application yet. We'll download first the application from openvpn.net site. Install the application. OpenVPN Connect client is ready. I'll open a new tab to register the user for MFA. The URL again is aka.ms/MFA setup. Let us go through the setup process. Instead of receiving a code on a phone, I want to set up a different method using email. Looks like we are done. Under security info, we can find that Microsoft Authenticator Push MFA is available. Back in Entra, OpenVPN IT User 1 has now a default sign-in authentication method, that is Microsoft Authentication Notification. Next, we'll go to Pfsense and perform an authentication test. I did not receive notification on my phone and it got failed right away. What do you think the reason why we got an authentication failed error for OpenVPN underscore IT user 1? Is it related to the NPS policy? We did not add the IT group yet. Back at the server, let us check the event viewer. There is a recent entry and it says NPS extension for Azure MFA only performs secondary auth for radius request in access accept state. Request received for user OpenVPN underscore IT user 1 with no response state access reject, ignoring request. It did not perform a secondary auth since the request already failed during the first auth to NPS. Open NPS and edit the network policy. Under conditions, we have users group in here and no IT group yet. Double click, then add the IT group. Do another authentication test. This time I did receive the notification on my phone. We got a successful authentication. Event viewer's latest entry now says access accept for user OpenVPN underscore IT user 1. Now that authentication has been taken care, Next, we'll go to certificates to create a user certificate for OpenVPN underscore IT user 1. Before we proceed further, I wanted this OpenVPN underscore IT user 1 to have a static source IP so that I can match this exactly on a firewall rule, permitting these networks. So whenever this user connects to OpenVPN, the firewall knows that it's OpenVPN underscore IT user 1 and then it gets a static IP address. How can we achieve that? We'll configure client-specific override by going to VPN, OpenVPN, then select client-specific overrides. Click Add. For the description, I'll just put here for IT group. For common name, this will be the exact username, OpenVPN underscore IT user 1. In server list, we only have one configured. Now for this IPv4 tunnel network, this is where we put a static IP, and I'll designate 172.20.0.100/24. When OpenVPN IT user 1 authenticates, it matches the user common name, and then assign the IP 172.20.0.100. For IPv4 local networks, this will be the permitted network resources 192.168.1.0/24, 192.168.10.100, and 10.10.10.0/24. I'll leave the other settings as is. Click Save. We just created a client-specific override for OpenVPN underscore IT user 1 for the purpose of securing a static IP and allowing specific resources for access. We can take advantage of the static IP with the firewall rule, which we'll configure next. But before that, we'll download the OpenVPN configuration file for OpenVPN underscore IT user 1 under client export. We go to Firewall, then Rules. Under OpenVPN, we have this firewall rule for SMB, but it is covering the whole subnet of 172.20.0.0/24. We'll add a firewall rule on top of this one exclusively for OpenVPN underscore IT user 1. For the protocol, I set it to any. For source, this will be the static IP that we designated for OpenVPN underscore IT user 1 in the client-specific override section earlier. That is 172.20.0.100. Destination would be the 3 network resources, but how can we add this since we can only put one network in this firewall rule? This can be done with aliases. I'll open a duplicate session for the web management. We go to Firewall, select Aliases. Under IP, click Add. I'll name this all underscore networks. Change the type from hosts to networks. I'll start with 192.168.1.0/24 for the LAN. Add network for 10.10.10.0/24, that is the DMZ. Add one more for 192.168.10.100/32, that is for the file server. Click Save. We just created an alias name all_networks that covers the three networks. We can use this alias name into our firewall rule. Back in the first tab, in the destination field, instead of network, we'll select address or alias, then enter the alias name all_networks. In the description, I'll say that this is for IT users management access. Click Save. We just configured a firewall rule matching the source IP 172.20.0.100 going to the destination alias name that has the three networks. At the remote user machine, I have OpenVPN Connect client open ready to import the configuration file for OpenVPN_IT user 1. Push notification is received on my phone by Authenticator app, and approving it, we have a successful connection. As expected, OpenVPN_IT user 1 has been assigned the static IP 172.20.0.100. Open command prompt to verify connectivity. Pinging 192.168.1.1, which is Pfsense LAN IP, is reachable. Pinging switch management IP 192.168.1.205 is also reachable. We have connectivity pinging AD server 10.10.10.220. Same goes with the file server 192.168.10.100. Let us also test connectivity via web browser over HTTPS. Pfsense Web Management 192.168.1.1 is accessible. Switch Web Management 192.168.1.205 is also accessible. Let us test RDP connection to the file server 192.168.10.100. We have a successful RDP connection. Lastly, an RDP connection to the AD server 10.10.10.220 is also a success. Examining the event viewer latest entry for Azure MFA, we can find the accepted access request for user OpenVPN_IT user 1. Looks like we are able to achieve the goal for OpenVPN_IT user 1. In terms of troubleshooting, this guide has a link to a script called NPS extension health check script, which you can download to the AD server. Let us jump to the AD server. For troubleshooting again while we are at the event viewer for Azure MFA, you can start looking here and check for errors. Here is one issue that I have encountered and saying access rejected for this user because no default authentication method is set for the user. I forgot to register the user for MFA when I was testing this one. Another thing to point out that user created on on-prem AD server will not sync right away to Entra, and the default sync time for this agent Microsoft Entra Connect sync is 30 minutes. You may want to change the default sync time to a lower value or do a manual sync. Here is the file that we can use to troubleshoot NPS extension that I have already downloaded from that guide earlier. It is a zip file and have to extract it first. What we need to run here is the file name MFA underscore NPS underscore troubleshooter.ps1 in PowerShell. You may get this error that says cannot run the script on the current system or having unauthorized access. To bypass this error, just type this command: set-execution policy-scope process-execution policy bypass. Enter Y for yes, then run the script again. And it says here, welcome to MFA NPS Extension Troubleshooter Tool. This tool will help to troubleshoot MFA NPS extension issues. There are 4 options to select and just pick one depending on the issue. Here is another guide that you can take a look at listing the common errors that can be seen in Event Viewer log entry for Azure MFA. As an example, we have seen this error, no default authentication method is configured, and we can find recommendation to resolve it. One more guide to look at is entitled Integrate Your VPN Infra with Entra MFA by the NPS extension for Azure. I'll share the links of these guides in the description. I missed to point out this step that I added in the server registry. In order for an NPS extension to continue working for VPN users, this registry key must be created on the server running NPS. I'll open registry editor on the AD server running NPS. The location is HKey local machine, software, Microsoft Azure MFA. This string value pair override number matching with OTP is set to false. There are some useful information here in case you encounter an issue. I just wanted to point out one more thing when installing the NPS extension. You will need to download and install the NPS extension executable file on the on-prem server running NPS. The screenshot here shows what it looks like upon successful installation. After that, a script that came with the installation of the NPS extension at this location must be run in PowerShell. Location of the script is at C, Program Files, Microsoft, Azure MFA, then Config. The name of the script is Azure MFA NPS extn config setup.ps1. Open PowerShell and enter that name of the file. The script will install the required packages, then it will require to sign in with Entra Tenant ID. Back at the guide, we have screenshots of what it will look like for the first time running the script. Take a look at this so that you know what you'll expect when installing the NPS extension. That's it for this video and see you on the next one.